Hey everyone, welcome back to nutrition. So we are going to get started with the 6 classes of nutrients, and these are going to be pretty familiar from your probably health classes that you've taken about human nutrition. But there are a lot of similarities between animal and human nutrition, obviously, and this is one of those things. Like we need the same basic nutrient classes in our diets, right? So we're going to get started here. The 6 major classes or areas of nutrients all animals require in their ration are water, protein, carbs, lipids or fats, minerals, and vitamins. Okay? So, water is the most essential nutrient. It is oftentimes one of the most overlooked nutrients, however. Okay, but access to fresh, clean water is super important for our animals. Functions of water include transporting nutrients and aiding in excretion. Remember, that's pooping and urinating. Allows chemical reactions, body temperature regulation, and lubrication of joints and organs. So all of those are very important and are accomplished by water. Water accounts for 90 to 95% of our blood, 70 to 90% of our tissues, 65 to 85% of our body weight at birth, and 45 to 65% of weight at maturity. The percentage of body water decreases with animal age and has an inverse relationship with body fat. So basically, that means that the more older we get, including animals, the less water we have in us, okay? And the inverse relationship with body fat. So as body fat goes up, the amount of fat we have, the amount of water we have goes down. That's water. The second one is carbohydrates. Carbs are the things that a lot of us probably like, especially as humans. Like I know I'm a sucker for spaghetti meatballs with a breadstick and maybe a piece of cake for dessert. That's very carbohydrate heavy. Probably isn't the most healthy either, but carbohydrates can be good. The carbohydrates are the main source of energy in animal diets. They are classified either as structural or non-structural. Structural carbohydrates are digested by microbes in the hindgut, the source of energy in bulk. So that would be your forages. Remember, forages are high in fiber and lower in energy. Non-structural carbohydrates are digested by enzymes and stored in the foregut. Carbohydrates are just what they sound: carbon, hydrogen, and oxygen. The ratio of carbon to hydrogen to oxygen is 1:1. So that means for every carbon atom that we have 2 hydrogen atoms and 1 oxygen atom. So the example of glucose is C6H12O6. Kind of see that pattern? We have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So it kind of follows that formula up here, CH2O and then N. You multiply it. It's like algebra, right? Each carbon is hydrated with a water molecule, hence the name hydrates of a carbon or carbohydrate. CHOs, or carbohydrates, are classified by the character of individual monomers, the degree of polymerization, and the types of linkages, alpha or beta. And I'm not going to expect you to memorize these chemical structures by any means, but it is kind of important to know, especially because this class counts for your chemistry credits. So over here in this diagram, we see the difference between an alpha and a beta linkage. An alpha linkage is going to have hydrogen on the top and OH on the bottom, and beta is going to be flipped. Monosaccharides are a type of carbohydrate that are also called simple sugar, and this is the simplest form of sugar and the most basic units of carbohydrates. They cannot be further hydrolyzed into simpler chemical compounds. So glucose, fructose, and galactose are examples of monosaccharides. Okay, you see these are very simple. They have a simple structure. That's going to look different than our disaccharides, which are right here. Disaccharides are 2 monosaccharides linked by a bond, a glycosidic bond, the type of bond that links simple sugars together into more complex carbohydrates. And that is that bond right in here. We have those 2 monosaccharides to make sucrose. Other examples are sucrose, lactose, and maltose. And lactose is what is found in our milk. And some people are lactose intolerant because they're unable to break down. Actually, all people who are lactose intolerant are unable to break down properly with their body condition this specific disaccharide. It's very complex. So you see the difference. Glucose is 1, monosaccharides are 1, like glucose and fructose, and sucrose are linked together, and that's a disaccharide. Okay, that's another picture just so you can take a mental snapshot. Another example. I would encourage you to watch the brain break that I have posted for you. It is a video about how some farmers supplement Skittles into dairy cattle diets as a source of additional energy, because Skittles are a carbohydrate and they provide energy. Okay. We are going to go into lipids and fats then, and then we are going to take a break. Lipids and fats. Lipids are defined as insoluble in water, but soluble in organic solvents. Remember, soluble means that we're able to dissolve it and work it into the liquid that we have, and insoluble means we cannot. So fat sources can be plant or animal-based. They are required for absorption of fat, soluble vitamins, and they're the most energy-dense nutrient. 1 gram of fat yields about 9.45 kilocalories, or calories as we call them in America, of gross energy or heat, compared with 4.2 kilocalories for typical carbohydrate. Okay, so now we get into our proteins, and this is where we are going to stop. So next time we are going to finish out these 6 classes of nutrients, and we'll move on from there.